Okay, so number one, amplitude. We're asking about amplitude. That would be 2. The period is 360 divided by b. B being 2, 360 divided by 2 is 180. Vertical shift would be the k value, which is a positive 1. The phase shift or horizontal shift, you can call it whatever you want. I'm going to call it HS for horizontal shift. We're going left because we're the opposite direction. Left pi over 4, which is 45 degrees, if you'd rather do that. So I'm going to go ahead and make some marks here. My vertical shift of 1, so I'm going to start at positive 1. I guess I'm going to do a horizontal. I'm going to turn my paper sideways so I can draw this a little easier. My amplitude is 1, so I'll go 2, or amplitude is 2, so I'll go 2 above that, up to positive 3, and 2 below my midline, which is at negative 1. Okay, then I come back. Horizontal shift was left pi over 4, or 45 degrees, so that's kind of right in between the 0 and the negative 90. Okay, I think I'm ready to start graphing. So this is a sine graph which starts at the midline. So go to that negative 45 to the midline, put a point, then it goes up unless it's flipped, and it's not. So I should pay attention to this. My period is 180. So if I take 180 divided by 4, I get 45 degrees. That means every 45 degrees is my next angle that I care about. So from negative 45 to I go to 0, and then to positive 45, to 90, to 135. I think that's 1, 2, 3, 4 of them after the original. So I'm going to go to the positive 135, and then I'll be finished with my period. So, okay, so back to the midline. So the 0 will be up at the max, and then back to the midline when I'm at 45. When I'm at 90, I'm down at the minimum. And when I'm at 135, I'm back at the midline. So connect the points, and we have our period. Number 2, amplitude is 1/2. Period 360 by 1, so it's just 360, which means I'll get to go by 90s. That's convenient. Vertical shift, looks like I would go down 3. Horizontal shift, I'm going left. Left 2 pi. I don't know why I started that last time horizontal. I said left versus, and then on vertical I just gave a positive. So you can, I don't care how you do it as long as I can see it in the picture. But my vertical shift is at negative 3. So once again, I'm going to turn my paper so I can draw that a little better. With an amplitude of 1/2, so I stay pretty close to that midline. Okay. Shifting left 2 pi, so 360 degrees. And it takes me 360 to do an entire period, so if I start at negative 360 and add 360, I get to 0. So from negative 360 to 0 is where my period is I'm going to do. Cosine starts at the maximum. It was not flipped, so I start up here at the negative 2.5. Then by the negative 270, I'm at the midline. By negative 180, I'm down at the minimum. At negative 90, I'm back up to the midline, and then at 0, I'm back up to the maximum. Then the next period starts at 0, which really I could have just started at 0 and done the next one. That would have been acceptable as well. Number 3, our amplitude is 4, is the absolute value of A, so I don't need to include the 4, the negative in my amplitude. B value is 1, so our period's still 360. Vertical shift, there's none. Horizontal shift, I'm going left 3 pi over 2, that's 270, however you want to call it. And 360 divided by 4 is 90, so I'm going by 90s after that. So 1, 2, 3, 4 of them, so I'll finish the period at 90 degrees. My amplitude is 4, so I'm going to go up to 4 for a maximum, down to negative 4. Cosine problem. Cosine starts at the maximum unless it's flipped, and it was. The a value is negative, so I will start at the minimum when I'm at my negative 270. Then I hit the next I hit the midline, then I hit the maximum, then I'll hit the midline, then I'll hit the minimum. Number 4, amplitude is 1. Period here. So it's 360 divided by 3, so it's 120. When I cut 120 into fourths, I'm going to go by 30 degrees. So every 30, I'm just kind of penciling them in real quickly. Those aren't actually, as we'll see in a little bit with my shift, those are not actually the points I'll be using. But I'm cutting the 90s into thirds. Okay, my vertical shift, there is none. Horizontal shift, it's negative, so I go the opposite direction. I go right 40 degrees. So right 40 doesn't end up nicely on one of these points. Oops, I don't know why I did that one. That was about 70 degrees. I guess I'll end up doing that anyway. But here's 40, so then 70 is about there, 100's about there, 110, 140. Or 150 rather, it's not 140, so it's going by, it should go up to 160. So I start at 40, and then I go over 30 from there. So 70, 100, 130, 160. So I will finish at 160, because I started at 40, and a full period is 120. 40 plus 120 is 160. So I will be finishing the whole thing at 120 degrees. My midline was at 0, my amplitude's at 1. Okay, sine starts at the midline, so it starts at 0. This is repeating very quickly. I might use a different color so it'll stand out a little bit better. Got kind of a busy graph going on here. So it's still, I know, a little hard for you to see there, but it repeats quickly because it repeats every 120 degrees. Okay, now number 5. Amplitude is 1. Period. It's a negative 1, so it's still 360. And negative b value does not flip the cosine, so this is not flipped. If it were sine, it would have been. Vertical shift, it went down 2. Horizontal shift, there is none. Shifted down 2 with an amplitude of 1. It's not flipped, so cosine starts at the maximum, then goes to the midline, down to the minimum, back to the midline, back to the maximum. Then number 6. Our amplitude is 3/2. Period 360 divided by negative 1/2, that's the same as 360 times 1/2, so that's 720. So 720 divided by 4 is 180, so I'm going to be going by 180s. I'm not going to use every 90 degree. Okay, let's go shifts. Vertical shift, we're going up 4. Because I didn't stay very consistent, I wrote up this time. Horizontal shift, there was none. With an amplitude of 1.5 rather. 3 halves would be 1.5. Down 1.5. Alright, so we didn't shift horizontally. It's sine normally, or sine always starts in midline, whether it's flipped or not. So we know it's going to start in the midline. Then sine normally goes up. Was it flipped? Well, the a value is negative, but so is the b value. And in sine, both of those flip it. So the double flips means that it's not flipped. So I will go up, but I won't get to the max until I'm up to 180 because of that slow period. So then I'm back to the midline by the 360. By the 540, I'm at the minimum, and by the 720, I'm back to the midline. Okay, let's go to the back page. Arc sine of 1/2. So sine, and it's positive, we're going to be in the first quadrant. So our sine is opposite of our hypotenuse, so our opposite is 1, our hypotenuse is 2. Now this looks like a 30, 60, 90 triangle. And opposite the 1 is 30. So our reference angle is 30 degrees. That's in quadrant 1, so if I start here at the 0 and travel to that point, I've traveled 30 degrees in the positive direction. So positive 30 degrees as in radian, that's pi over 6. Number 8, cosine. It's negative, so we put that in the second quadrant. Cosine's adjacent or hypotenuse. Oh, this one is, I know it's been rationalized because I see the same number in the top and the bottom, and there's a square root in the top. So since it's square root of 2 over 2, I know it's been rationalized. Divide out a square root of 2 from both the top and the bottom. Square root of 2 divided by square root of 2 is 1. 2 divided by square root of 2 is square root of 2. So I'm going to replace it with that unrationalized version. So cosine is adjacent over hypotenuse. So our adjacent is -1, hypotenuse is square root of 2. So then that opposite side would be 1. That's a 45, 45, 90 triangle. My reference angle is 45 degrees. But if I start here at 0, that means I travel 135 degrees, which is a fourth of pi 3 times, or 3 pi over 4. Arctangent. Tangent is negative. We put that in the fourth quadrant. Opposite over adjacent. We put it as a fraction over 1. So opposite is -1. Adjacent's 1. That's a 45, 45, 90 triangle. Reference angle is 45 degrees. To get there from the 0, I have to go backwards in a counterclockwise, or in a clockwise fashion. So it's negative 45 degrees, or negative pi over 4. Number 10, inverse sines, negative. So sine in the negative, I go to the fourth quadrant. Opposite over hypotenuse. I know the other side's 4. Now this is actually, I just realized as I got to this point, that I told you in class for numbers 10 and 11, they accidentally slipped onto this. I made the worksheet really quickly. That's not a special right triangle. We don't know what that angle is unless you're using a calculator. And the intention was to give you ones that you didn't need to use a calculator for. They didn't pan out here. That should work out on the quiz though. We'll take a little more care coming up with questions on the quiz than what I did for this worksheet. So I do actually need to use the calculator to do this problem. That was not the intention. Maybe I can't. Okay. Sorry, I'm trying to get that to show up well. So I need to do second sine. Second sine, and you'll see that inverse show up. And then you can type in the -3/5. Hopefully you can see there, you can kind of see that inverse sine of -3/5. And we see that it is negative. They say round to the nearest, well, it'd probably say it's round to the nearest tenth if it was actually a calculator problem, or supposed to be. It would have been, so -36.9 degrees. And at that point, I'm not worried about making those radians because I didn't even like this problem. So should have not had 10 and 11 show up, but we do know how to use the calculator to find the answer to that. Since 11's like that, it's positive, tangent, first quadrant. Opposite is 13, adjacent is 12. That means the other side, it's actually, sorry, 13 and 12, I'd have to do Pythagorean theorem with 13 and 12. square root of 313. Yeah, I'll just call it square root. Doesn't really matter because I can't do this problem anyway without a calculator. And so we'll use the calculator. Since it kind of got on here accidentally, we would just do second tangent, 13 over 12. 47.3 degrees. Okay, then number 12, now we get back to being able to move, to proceed without a calculator. Arc cosine, oh, this is cosine of a -1, that means it's a quadrantal. If you didn't catch that at first, you would have made it a fraction to do your adjacent over hypotenuse. At this point, you should realize that your adjacent and your hypotenuse are both a 1. I don't care that it's a negative, they're both a 1. It's not possible for our hypotenuse to be the same length as a leg. So there's a problem there that should tell us that it is, in fact, a quadrantal. So which one? You can think about your unit circle. Remember that cosine is the x value. Sine is the y value. You might remember y over r, x over r, y over x. Cosine was x over r, and our radius on a unit circle is 1. So x over 1 is just x. So we need to associate cosine with x. So this is telling us we have an x value of -1. So if you go to your unit circle, to your x-axis to -1, that means we're at that point, -1, 0. The question is, what angle is that? And remember, cosine, inverse cosine, we've got to be between 0 and 180. Well, it is, in fact, 180 degrees, which is the same as pi radians. Okay. Now we go to the bottom section. Here's an arc cosine of 0. That's another quadrantal. Like we just discussed, cosine is the x value, so we want an x value of 0. So if you go to your x-axis to 0, that means we could be up here at 90 or down there at -90, but cosine we know is defined as between 0 and 180. So we have to go between 0 and 180. So it has to be this point up here, which is the order pair 0, 1. Now the question, so it's a 90-degree angle, but the question is, what's the sine of that value? Well, the sine is the y value. So what's the y of that order pair? That's 1. 1 is your answer. Number 14. So we start with inverse sine of -3/5. Inverse sine is negatives in the fourth quadrant. Sine is opposite over hypotenuse. Opposite is -3. Hypotenuse is 5. That's a Pythagorean triple. You could use your Pythagorean theorem if necessary. If you do plug in -3 into the Pythagorean theorem, put it in parentheses, so when you square it, it becomes a +9. But you get 4. 4 is the other side. Of this triangle now, of that angle, we need to do tangent, so that's opposite over adjacent. So do your opposite, which is -3, over your adjacent, which is 4. You've got your answer. Number 6. Arc sine. So sine is positive, so it'll be in the first quadrant. Opposite, square root of 3. Hypotenuse is 2. I didn't bother. I knew I couldn't unrationalize this because there was a 3 in a square root, 2 in the number. They're not the same number. I don't need to rationalize that. This is, in fact, two sides of a special right triangle, where the other side is 1. Now, of that triangle, do cosine, which is adjacent, which is my new value. I just found 1, over the hypotenuse, which is 2. So 1/2. Number 16. Talking about inverse tangent, it's positive, so that's going to be in the first quadrant. We got to put it over 1, so opposite is square root of 3 over adjacent, which is 1. Hypotenuse there is 2. That's a 30, 60, 90 triangle. The sine of that, sine is opposite over hypotenuse, so that's square root of 3 over 2. All right, thanks for watching.